Welcome back. From this section onwards, we're going to implement a change of gear in the course. And we're going to be focusing mostly on how to use the different Python libraries that are available for hyperparameter optimization. In the first half of the course, we focused mostly in understanding what we need for hyperparameter optimization and in understanding how the different algorithms to tune hyperparameters work under the hood. So we had a section dedicated in metrics, which are values that we need to optimize because they indicate the performance of the model. Then we had a section on cross-validation, because cross-validation allows us to understand the error of the models that we train. Then we had a section on basic hyperparameter search algorithms. From there, we moved on to Bayesian optimization, and we wrapped up with multi-fidelity optimization that combines the use of expensive and cheap models to speed up the search for hyperparameters. So from now onwards, we're going to be focusing mostly in understanding how the different libraries for hyperparameter optimization work. There are many libraries for hyperparameter optimization in Python. These 6 are by far the most popular ones. Of course, Scikit-Learn has hyperparameter tuning tools as part of its ecosystem to tune the models that we train with Scikit-Learn. We have Scikit-Optimize, which was also developed by some of the developers of Scikit-Learn that implemented for the first time Bayesian optimization in a way that is compatible with the Scikit-Learn ecosystem. You probably heard of Hyperopt. Hyperopt was one of the first libraries to implement Bayesian optimization, and it was in fact developed by the authors of Bayesian optimization using 3% estimators. So it's one of the most popular libraries because it has been out there for a long time. And recently, like 5 years ago or something like that, Optuna came in, and it was revolutionary because it's the first Python library for hyperparameter optimization that allows us to optimize hyperparameters using a Pythonic way of coding. And I'm going to say more about all of this in the relevant sections on Scikit-Optimize, Hyperopt, and Optuna. In addition, we have Keras Tuner, which is an additional library to support the tuning of models that you build with Keras. You can use Keras Tuner to optimize models of Scikit-Learn, but I personally don't see why you would do that when there are other libraries available that are much better. And finally, we have a very popular library that is called RayTune. And in fact, the library is called Ray, and Tune is one of the modules that this library has to optimize the hyperparameters. In the course, we're going to be focusing on Scikit-Learn, Scikit-Optimize, Hyperopt, and Optuna. And we're going to leave Keras Tuner for now because, from my perspective, this library would only be useful if you're using Keras, and you can optimize Keras models with Optuna as well. And we're also going to leave RayTune for the time being. Now, as I said, these are some of the most popular libraries, and here I rank popularity by the number of downloads from PyPy per week. And as you can see, Optuna is the library that is more popular so far, and Hyperopt takes the second place. 5 years ago, this was not the case. Actually, Hyperopt was the most popular and Optuna was just coming up. But now Optuna has clearly positioned itself as the default library for hyperparameter optimization, and we're going to see why in the Optuna section. Ray is a multifunction library. It's not just for hyperparameter optimization. In fact, hyperparameter optimization is just one of many modules. That's why here we see that it has a lot of downloads, but it's hard to say from this number of downloads how much it's downloaded for the use of hyperparameter optimization. So we're going to leave this out of the equation for the time being, and then we see that Scikit-Optimize positions itself in the third place. But there are other libraries that are far less popular, like one library called Bayesian Optimization, Scikit-Learn, GPY Optimization, Spearmint, and many others that I have not put here, like Hypergrad, Teapot, and Smack. And the reason that I haven't put them in this slide is because these libraries are not so popular, are not so well adopted in the community. The documentation is weak and they are not actively maintained. So if any of its dependencies gets an update, for example, most likely Scikit-Learn or NumPy or Pandas, then these libraries may not work for a while until the maintainers kind of catch up. and some libraries are also not maintained anymore. So we're going to focus in the rest of the course on the most popular libraries, those that are here to stay at least for a little longer. So from the 4 libraries that we'll focus, Scikit-Learn is the go-to library for hyperparameter optimization when you're training Scikit-Learn models. So my advice is that if you're training models from Scikit-Learn, tune the hyperparameters also utilizing Scikit-Learn. The reason being is that Scikit-Learn models are fairly simple and they don't have that many hyperparameters. And even if they do, remember that only a few of the hyperparameters really drive the performance of the models and the other ones don't affect so much. So we don't really need to make any complex hyperparameter optimization search. With randomized search, we are good to go. And also, Scikit-Learn has successive halving if we want to accelerate the search for hyperparameters. If for some reason you want to use Bayesian optimization and want to remain compatible with Scikit-Learn, then Scikit-Optimize is your go-to library because it implements Bayesian optimization with Gaussian processes or random forests in a way that is compatible with the search and how we set up searches for Scikit-Learn models. So as I mentioned previously, Hyperopt is a veteran in hyperparameter optimization. It was developed by the authors of Bayesian optimization with 3% estimators, and because of this, it has positioned itself as a leader library in hyperparameter tuning. It has been adopted widely by the community, and perhaps for this reason, it continues to be used, even though the maintenance of this library is not the best, and the documentation is also a bit poor. And Optuna is the newcomer. The revolution with Optuna is the Pythonic way in which we write the code to tune the hyperparameters. It uses a design by Ryan API that basically allows us to sample for hyperparameters as we write the code instead of creating hyperparameter spaces. And Optuna also supports most of the hyperparameter search algorithms that we discussed so far. So for these reasons, if you're tuning hyperparameters with Scikit-Learn, I would suggest that you stick to Scikit-Learn. But if you're tuning hyperparameters for other libraries and you want to pick one library to learn, then I would suggest you focus on Optuna. And if for some reason you've started using Hyperopt and want to stick with it, by all means do it. This is also a great library. And in this course, I will tell you more about the different components of Hyperopt and how you can use them in your favor. So before wrapping up this video, let's say a few more words about the methods that each of these libraries support. Throughout the course, we've discussed several methods for hyperparameter optimization. We talked about basic methods like grid search and random search. Then we talked about Bayesian optimization, and we saw that we can infer the distributions of hyperparameters using various models, including Gaussian processes, random forest, and 3% estimators. And we then talked about multi-fidelity optimization, and within these methods we discussed successive halving, asynchronous successive halving, and hyperband. So one reason to learn perhaps more than one library could be that not all libraries support all methods. In particular, random search is indeed supported by the 4 libraries, but grid search is only supported by Scikit-Learn and Optuna, although I would find very rare that you will implement a grid search with Optuna. Bayesian optimization with Gaussian processes is supported by Scikit-Optimize and Optuna, but optimization with random forests and also gradient boosted machines is only supported by Scikit-Optimize. And if you remember from one of my previous videos in the section of sequential learning, some authors discussed that random forest is the best surrogate that we can use when we're looking for hyperparameters. But we also saw that there aren't really that many differences between the different surrogates, and in fact, the article that proposed random forest as the best surrogates is from the developers of random forest as the surrogate, so we should take this a little bit with a grain of salt. 3% estimators, which has been by far the most popular Bayesian optimization method for hyperparameters, is supported by Hyperopt and Optuna, and this spin-off randomized search, which is called annealing, is supported only by Hyperopt. Now, among the multi-fidelity optimization, Scikit-Learn supports successive halving in a way that models compete with each other and winning models will pass to the next round. Optuna supports asynchronous successive halving, which basically takes into account the different computers or cores that we have at our disposal to evaluate the different configurations of models with the different hyperparameters. And it also supports hyperbound. Now, there is a difference between the methods supported by Scikit-Learn and Optuna. While Scikit-Learn retrains the models at each round, Optuna focuses on those models that can be trained iteratively and will stop models that are not promising. I will say more about this in the section on Optuna. So with this in mind, I hope now you have a clear view of which library is the one for you and which one you want to learn more about. And in the next 3 or 4 sections of the course, I will focus exclusively on each one of these libraries, and I will discuss more about the methods that they support and how we can implement them in Python. See you there.